This is the brief on fluid kinematics. Okay, so this is all about bridging the gap between abstract vector calculus and what fluids actually do. We're going to see how the math predicts where a fluid goes, how it spins, and how to calculate its mass flux, which is really just a way of saying how much stuff is moving. First up, the divergence theorem. This is what links the math to physical flow. If you get a divergence of 0, that means the flow is incompressible. Basically, what goes in must come out. It's not getting squished or spreading out. But if the divergence is positive, then you found a mass source, where fluid is actively pushing outward. Second, that brings us to the continuity equation. If divergence shows us where a fluid expands, this equation tells us what happens to its density. So, in those source regions, the fluid spreads out and has to thin out. And in sink regions, where divergence is negative, the fluid gets compressed and bunches up. Finally, there's vorticity, which is all about local rotation. The best way to picture this is with a tiny paddle wheel. In rigid body rotation, the paddle wheel itself spins, but in an irrotational vortex, the fluid moves in a circle, but the paddle wheel just orbits without spinning, kind of like a car on a Ferris wheel that never flips over. That's what zero local curl means. So really, these tools, divergence and curl, are what define the essential properties of any flow: its expansion, its conservation, and its rotation.